Okay, continuing with our video lessons. This video is going to help you with the last homework. Okay, we're going to practice the same type of exercises that are assigned in the homework, and if you have any further questions after that, you can let me know and I'll help you out. Okay, but these exercises that we're going to do right now are exactly the same as the ones in the homework. Okay, we're going to use the same formulas. The only thing is that we're going to change the numbers. Okay, but same type of exercises. Okay, so the first exercise is convert degrees to radians. Okay, remember that when we're converting degrees to radians, we're going to use two types of formulas. Okay, the one that says pi over 180 or 180 over pi. Okay, so that means that whatever the number that we have, okay, we're going to use one of these formulas. Okay, so for example, if I have degrees, okay, and I want to change it into radians, for example, let's say 150, okay, I have it as degrees and I want it as radians. Okay, so that means that I have to use this formula. Why? Because what I'm looking for is I'm trying to eliminate the degrees so that I can leave it in terms of pi. Okay, so if I multiply times pi over 180 degrees, if you notice, the units are going to get canceled. Okay, and I'm only going to have the terms in pi. Okay, and this is what I'm looking for. Okay, so once I have this, okay, once I have this settled, okay, now I multiply. Okay, 150 times pi, 150 pi divided by 180. Okay, now can I simplify this fraction? Yes. Okay, I can simplify. 150 divided by, let's say, 30. If I divide it by 30, okay, on the top, I'm going to have 5. Okay, and if I divide by 30 on the bottom, I'm going to have 6. Okay, so that means that in radians, I'm going to have 5 pi over 6. Okay, now I can write this number in a different form as well. Okay, I can write it as a decimal. Okay, that means that I have to multiply 5 times pi, okay, divided by 6. Okay, and technically my radian, okay, the measurement in radian is 2.61. Okay, so I can leave it in terms of pi, but I can also leave it in a decimal point. Okay, you can put both. It's either way, it's going to be correct. Okay, for me it doesn't matter. You can leave it as a pi or you can leave it as a decimal. For me, it's the same thing. Okay. Now, this is the formula that we use when we want to convert degrees into radians. But what happens if we have radians and we want to convert it into degrees? Okay, remember that the radians are going to be written in a pi form. Okay, so for example, if I tell you 6 pi over 7, okay, that's written in terms of radians, okay, in terms of pi. Okay, so that means that I have to multiply times the formula, 180 over pi. Why? Okay, remember, what I'm trying to do is simplify, okay, and convert. Okay, in this case, the pi is going to be canceled with the pi, and I'm only going to have degree units. Okay, and this is what I'm looking for, converting radians into degrees. Okay, so now, since I multiply 6 times 180 divided by 7, now, first, always try to simplify the fraction so that the multiplication becomes easier. Can I divide 180 by 7? No. Okay, so I cannot simplify. I just have to multiply. Okay, so that means 6 times 180, okay, divided by 7. Okay, so my measurement in degrees of 6 pi over 7 is 154.2, but we can leave it in 154 degrees. Okay, this one only has this form. Okay, we cannot change it into a decimal or anything else like we did with pi. Okay, but we only multiply, divide, and what we get, that's the measurement in degrees. Sorry. Okay, so we are using both of the formulas, okay, so that we can simplify. Okay, convert degrees into radians and radians into degrees. Okay, now the other exercise is find the circumference of a circle. Okay, remember that for the circumference of a circle, we're going to need a formula as well. Okay, the formula that we need is pi equals circumference over diameter. Okay, so we need to know what elements, what elements do we have and what elements do we need. Okay, for example, if I tell you find the circumference, okay, of a circle with a radius of 12 meters. Okay, if I want to find the circumference, that means that I need the diameter. Okay, because pi, I already know it. Okay, but remember, radius is equal to diameter divided by 2. Okay, so that means that if I have the radius and I want the diameter, I have to move this to the I have to move this here. Okay, and it's 2 radius equals the diameter. Okay, so if I have the radius, that means that it's 2 times 12 meters, and I'm going to have the diameter. Okay, so that's where you have to be careful. This formula for the circumference needs a diameter. So if I have a radius, I have to convert it into diameter first, and then I know the diameter. Okay, so 2 times 12, 24 meters is the diameter. Now I can calculate the circumference because I'm going to have pi equals the circumference divided by 24 meters, which is the diameter. Okay, and remember, circumference is the measurement of the line that embodies the circle. Okay, so it's like the perimeter of the circle. Okay, using a word that's similar, right? Okay, so I move the 24 to multiply by pi. Okay, so 24 times pi is going to be the circumference. Okay, and we know that we know that 24 is meters and that pi is 3.14. Okay, so 24 times pi, 75.39. 39 meters. That's the circumference of the circle. Okay? So whenever we have a circumference formula or a circumference measurement, we need to know that that is given as this formula. What if I have the circumference and I want to find the diameter? That's different, right? What if I tell you the circumference of a circle, let's say, is 50 meters. Okay? So I apply it in my formula. Pi is equal to 50 meters divided by the diameter. Okay? So that means that I have to move this here and this here. Okay? Because first I move diameter times pi is equal to 50. Okay, but I need to move the pi over here. Okay, so I'm going to have diameter is equal to 50 meters divided by pi. Okay, so the diameter is going to be 50 divided by pi, 15.91. But what if I asked you that it's not the diameter that I wanted, but the radius? Okay, if we have the diameter, we just divide by 2. And I get the radius, 7.95. Just in case, right? Because I was asking for the diameter. Okay, but just in case I were to ask you for the radius, you just need to divide the diameter by 2. Okay? Now, let's move on to the next exercise. The next exercise is asking for the next exercise is asking for the length. No, find the area of a circle. Okay. What do you need to remember about the area of a circle? The area of the circle is pi r squared. Okay, this is pretty simple. We need the radius. We elevate it to the square. We multiply by pi, and we have the area. And remember, since we're talking about an area, that means that the units have to be to the square. Okay, so let's say that I want to find the area of a circle with a radius of 13 meters. Okay, so I just put pi 13 meters to the square. Okay, so first I do the square, right? Okay, so 13 to the square, 169, times pi 530.92. 92 meters square. Look, and I already have the area of my circle. The same thing happens if I give you, for example, a diameter. Okay, what if I give you that the diameter is 20 meters? Okay, and I want to find the area of the circle. Okay, pi r squared. Okay, if we have the diameter, we know that the radius is half the diameter. So that means 10. Okay, so then I just apply pi 10 to the square meters. Okay, remember, units to the square. Okay, so that means 10 to the square, 100 times pi, 314.15. Let me put it here. 0.15 meters square. And I have my answer. Okay? Now, what would happen if I give you the area and I need you to find the radius? Okay, let's say that the area of a circle is 200 meters square. Okay, that means that I just apply the formula. 200 meters square is equal to pi, okay, radius square. Okay, so I move the pi over here first. Okay, so 200 meters square divided by pi is equal to r squared. Okay, so that means 200 divided by pi, 63.66. Okay, and that is r squared. But now I need to find the radius. So that means that I apply the square root to both sides. Okay, so that I can find the radius. Okay, so the square root of 63.66, 7.97 meters. Okay, now we stay with meters because we had meters square, but when I apply the square root, the units also downgrade. Okay, in this case, 2 meters. Okay, and the last exercise. Okay, the last exercise. Okay, give me a moment. I just need to find some space. Here. Don't worry about this. Okay, so it says find the area of a circular sector with diameter 7 and an angle of 75. Okay, here what you need to remember is that the area of a circular sector, okay, is equal to pi r square n divided by 360. We know what is pi. We know what is r. N is the measurement of the angle in degrees. Okay, so that means that we need to have a measurement of the angle. Remember that a circular sector is like this. Okay, we have this radius, we have this radius. Okay, so r and r, and we have the measurement of this angle. Okay, this is n. Okay, because we're trying to find the measurement of all of this sector. Okay, so we need to include the angle of the measurement of an angle, and we have to divide it by 360. Why? Because remember, all of the area is practically 360, the area inside the circle. So we divide it by 360 because we're just trying to find this piece. Okay, so area of a circular sector. Okay, we need radius, let's say it's equal to 21 meters, and that the measurement of the angle is, let's say, 50. Okay, so that means that we apply our formula. Area of a circular sector, okay, is going to be pi r squared, 21. Okay, so 21 to the square. N, what is n? The measurement of the angle, 50. Okay, and all of this divided by 360. Now look at the units. Remember always the units. Okay, the radius is meters to the square. We have a degree, an angle, sorry, which is degrees, divided by 360 degrees. These units get canceled. Okay, pi doesn't have units, so that means that since we're talking about an area, okay, we're going to have meters to the square. Okay, but now we have to do all this multiplication. First, 21 to the square, 441. Okay, times pi, 1,385. Times 50, 69,272. Divided by 360, 192.42. Meters square. Okay, and that's my answer. Okay, all we need to do is place the values where we need the values. Okay, in this case, radius, angle, pi, we already know it, and 360. Okay, we just do multiplication and we find the answer. And the same thing happens if I give you an area of the circle, of the circular sector, and I want to find, let's say, the angle. Okay, let's try with, let's say that the area of the circular sector is 300 meters square. Okay, that means that I need to find this. The radius, let's say it was 5 meters. Okay, so that means 300 meters square is equal to pi, we already know it, radius, 5 meters, angle, we don't have it, divided by 360. Okay, so whatever values we have, we put them. Okay, so 300 equals pi 25 meters square, n, we don't have it, divided by 360. Okay, so the 360, I'm already going to move it to the other side. Okay, multiplying. Okay, so that means 300 times 360. Oh, that's a big number. Okay, 108,000. Okay, and we have pi 25 and n. Okay, so eventually this is going to move here dividing. So let's just put it directly. Okay, because remember, when I'm trying to find n, if this is multiplying, I move it to the other side, dividing. So let's just move it directly. Okay, so we have 25 pi. Okay, it's going to be equal to n. Okay, so we have first 25 pi. Okay, 78. But then we have 108,000 divided by this answer. Technically, the angle is going to measure, that's a big number, right? But I just invented the numbers. But this is what it would be. 1,375. And that's going to be the measurement of the angle. Okay, I know it's a big number and we wouldn't use it anyway, but this is just calculating with made-up numbers. Okay, but this is how we find it. Okay, I used big numbers. That's what, that was a little wrong on my part. Okay, but okay, we needed an angle. Okay, that covered these measurements. Okay, but this is just, I was just explaining the procedure. Okay, so if you have any questions, please let me know. Remember that these exercises are the same as the one in the homework. We just changed the numbers.